Here we go. Find x. Well, how am I going to find x? Well, I know it's a right triangle. So there's some things I need to understand. So, is it a special triangle? Well, I look up here and I don't see any 30s or 60s or 45s. Right? And I don't see anywhere where it shows that it's an isosceles triangle. So that would be a 45, right? And, or not always, but if it was a 45, or if it was an isosceles right triangle, where your legs were the isosceles, then, well, that's the only way it could be. So, an isosceles right triangle, then I would know that that's a special triangle, 45, 45. You guys don't even know about that yet, because I taught that the third period, not you guys. But this one I do know. If I think way back, long time ago, Algebra 1, maybe. Pre-algebra, maybe. 7th grade, maybe. Whenever, 6th grade. Pythagorean Theorem. Ring a bell? Anyone?
Is that one? Like
A squared plus B squared plus C squared.
Yes. A squared plus B squared equals C squared. Now I seen someone do this the other day on the maps, but they had C in the wrong place. Not naming names. No, just kidding. Alright, so, but the point is, we have to know where C is, right? So where is C, Sim? Where is C always?
At the end.
At the end, okay.
But on the thing, it goes on the, obtuse.
Obtuse, almost.
Like,
Hypotenuse.
Yeah.
There you go, hypotenuse. And it's, the hypotenuse is always where?
The longest
The longest side, good. And it's the side across from?
The right angle.
That's
90
right.
degrees.
Because the way this works is the biggest side is across from the biggest angle. And if this is 90, that means these other two angles are less than 90, right? Because they have to add to be 90. So we know that these sides are less than that side. Okay? So that's the one thing we know. C is here. Okay? We also know that A squared plus B squared equals C squared. Right? Pythagorean theorem. So, definition of Pythagorean theorem. No, that says pi. I get it because, but you might want to do TH. I don't know. I'm good with pi. If you want to write the whole thing, Pythagorean, that's cool. Alright, but where's A and B?
A is X.
Okay. Does it have to be?
Doesn't matter.
It doesn't.
They're both like
So-
equal basically.
So that's the thing with A and B. A and B can be transposed. The legs can be A or B. It doesn't matter. The hypotenuse is always C. That's what matters. Okay? And so once you have that, now you can plug some things in, right? So you have, what's A again? X squared plus, what's B? 10 squared equals what's C? 12 squared? Good. And so what did we do there? Substitution. Good. This is getting a lot easier, eh? The hard part was coming up with that definition of Pythagorean theorem, but then substituting in, that we've been doing that all year. So this is going to get a lot better, I hope, this semester. All right, what's next? Yeah, simplify. 10 squared, right? What is 10 times 10? Because x times x is x squared, so that's done. 10 times 10? 100, not 20. Right? A lot of people will put 20 because they're doing 2 times 10. It's 10 times 10 because there's 2 10s. And 2 12s, 12 times 12 is 144. Good. All right. Okay. Then what?
So we have to.
Oh, yeah, we have to say what we did, huh? So that was simplify, right? Sorry about that. And then subtraction, good. I heard it. And I'm doing it to both sides, so what does that mean? Yeah, subtraction property of equality. So I get x squared is equal to 44. Alright? Then what? This one's a little confusing, right? Because right now we're doing sad math, right? Subtraction, addition, division, multiplication, exponents. So this next one is an exponent, right? So we're finding the square root. Okay, the square root of it. What is that called? What is it called when we're doing, instead of subtraction, property of equality, division, property of equality, exponential property of equality, okay? So the exponential property of equality, okay? So what we're doing is we're saying, hey, the square root of x is equal to x to the 1/2. That's what square root is, right? So the square root of x squared would really be x squared to the 1/2, right? And what's 1/2 of 2? 1. And that would equal x to the 1. And that's what's happening there. We're using our exponential rules and we're doing the opposite, right? So since we're squaring, the opposite of square, opposite of 2 is dividing by 2, right? But we're doing it in the exponent, not just dividing. Does that make sense? Instead of multiplying by the power of 2, we're multiplying by the power of 1/2. Does that make sense? Okay, so we're going to say square root of x squared is equal to the square root of 44, because I have to do it to both sides. Now this becomes x, and this becomes, well, the square root of 44. Now what do we do? And if you remember back to distance formula, right? Flip it, smack it, rub it down, hey, right? What did we do with 44? We had a 44 here, right? And we broke it down. We said, hey, what goes into 44? What prime? We're doing prime factorization. So what prime number, starting with the lowest prime, right? Oh, it's covered up here, remember? 2, 3, 5, 7, 11, 13. One of the first things we learned this year. Now we're using it again. And this is going to happen all year long. The stuff we use at the beginning, we use at the end. Okay? That's why it's math is so important to keep your notes. 2. That's the lowest number because it's even, right? Okay, so 2 goes into 4 twice, 2 goes into 4 twice. Okay, does 2 go into 22? Sure does. How many times? 2 goes into 2 once, 2 goes into 2 once. Does 2 go into 11? No. Does 3? Does 5? Does 7? Does 11? Oh, there we go. Alright. How many times? And when you get to 1, you're done. Except remember, now the way they wanted to teach you is, hey, we have 2 to the second power times 11 to the first power. And we're bringing that to the 1/2 power. And so what's 1/2 of 2? That's just 1. What's half of 1? Well, that's a half, right? And so now you have 2 times the square root of 11. And that's the way they teach it in the book. And that's cool. I love it. Or take your pair Pull out 1. Why a pair? Because we're using 1/2. Because your root is 2. So we're doing pairs. If we were doing a cube, right? A cube, if it was cubed, we do a cube root, right? So we do triplets. If it was to the 4th power, we would do 1/4. So we take quadruplets, right? We look at how many how many sets of 4, how many sets of 5, how many sets of 7. Does that make sense? Okay. But we're just doing square root. So how many sets of 2? Oh, I got 2 of them. I'm going to pull 1 out. Do I have 2 of these?
No.
Then it stays rooted. It stays in the box. And so what did we do? We reduced it, or, sorry, that should be in a different color. We simplified, right. What we really did was PEMDAS with exponents. We finally did exponents, which is this simplification. Okay? And that is Pythagorean theorem. Let me go a little further because there's not a lot of these on the test. So, little further about this Pythagorean theorem. We have what's called Pythagorean triples. 3, 4, 5. 7, 24, 25. 8, 15, 17. 5, 12, 13. Okay? So let's look at our easiest one. Let's look at, now this problem's done, but I just want to look at a couple. So let's look at a 3, 4, 5 triangle. Okay? This is what we call a Pythagorean triple. And the reason why it works is this. That's C, right? A and B, or A and B, however you want to do it. Okay? So we got 4 squared plus 3 squared equals 5 squared. What's 4 squared? 16. What's 3 squared? That's 9. What's 5 squared? That's 25. What's 16 and 9? That's 25. So 25 equals 25. And that's how it works, guys. That's Pythagorean triple. So it's really, 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 really important to have these down. And I'm going to show you why. First, I'm going to show you over here. As soon as you're done with this, I'm going to erase it. You can let me know when you're done. I'm just going to keep talking until you're done copying. And then you can get to this stuff. So I'm going to use different colors. Oh, and this time I'm going to box them up so that you know they're separate from the equation. Okay? Let's look at that 3, 4, 5 triangle, but let's do it a little different. How about this? How about 12, 16, and what is this? 12, 16, and what is this? Now, we think 3, 4, 5. 3 times what is 12?
4.
Right. 4 times what is 16?
4.
Ah. So what are we going to multiply 5 by?
4.
4. So what's the answer here?
20.
And that is a fast way of doing Pythagorean theorem when you're doing ACTs, because it's timed. They're going to have these triples. Do you think they're going to give you a 3, 4, 5? Well, they might. They might. And they might give you a 5, 12, 13, 7, 24, 25. Right?
Wait, how do you know when it's going to be one of those?
You have those memorized, or you have them on the test and you see them. So here's one way of thinking about it. Here's another. Okay, so this was a different one altogether, right? So here's a, can I erase this yet? Has everyone got that copied? Who does not have this stuff copied? Because they can rewind and look, but you guys can't. So that's kind of why I'm kind of going with that. How far we got? Okay? So can I erase this number 2 part and start again with some Pythagorean? Because I just want to keep that going. And that way kids that already are done with this problem they don't have to watch this video anymore. But for students that aren't done with this problem, or are done with it but are having trouble with it, right? Then they might want to take a look at these Pythagorean triples. So how can we tell if they're a Pythagorean triple? That's a great question. So here we got this, boom, 25, 24, and x. Does anyone see anything about that that could be a Pythagorean triple? And why would it be? Now we can set it up as x squared plus 24 squared equals 25 squared, right? But we could also look over here and go, wait a minute, 24, 25, I remember that. That's 7, 24, 25. Done. As long as this is a right angle. Now let's look at it. What is 24 squared? That one's a tough one for me to remember. Is that like 624? What is that one? I forget. Who's got 24 squared? And 25 squared. Which one was that one?
24 squared is 576.
Okay. So what's 25 squared?
625.
625. There you go. 625. Sorry. 625 minus, oh shoot. 625 minus, what'd you say? 24 squared was? 576? Is that what you said?
I don't remember, hold on. 576, yeah.
Okay. And when I minus those, I get 49. So what's the square root of 49?
7, right?
Yeah, 7.
Boom. So it's 7. So there's two things. One, it takes you a long time, or two, have it memorized. Now on my test, do you have to have it memorized?
No.
No, you can have it on your cheat sheet, right? So if you have these numbers on your cheat sheet labeled Pythagorean triples, it's going to be a lot easier to tell. Like watch this one. See if you notice anything.
Wait, how do you spell Pythagorean? Okay, thank you.
You're welcome. I'm lucky I even did it that fast. I spell really not good. I was going to use a different word, but we're on film. Alright, so how about this one? Yes, sir. Oh, yeah. Alright, so, please grab a hall pass. So let's do this one. 75 and 75 minus